All right, guys, today's lesson is all about division. Now, I know how much everybody loves division. Yes, that was sarcasm. Either you love it or you hate it. And I think some of the reasons why we hate it is because one, we might not know our multiplication facts, or two, we don't know a process that works for us. So today I'm going to show you three different strategies, three different processes you can try and see which one works for you with division, okay? All right, so we've got 351 divided by 9. Now, a common mistake is that kids write this problem like this, but that is incorrect. That is not how we write it, all right? When we say the number 351, we write 351 divided by 9. Now, this is a standard algorithm that you have probably seen several years, and it works for some of us. We're going to start there. So the first thing we say is, how many times can 9 go into 3? Well, it can't. Some people put a 0 there. Some people put an X there. Some people just leave it blank. I'm just going to put an X there for today. So since 9 doesn't go into 3, then we combine it. And now we say, how many times can 9 go into 35? So 9 times what is something close to 35? 9 times 2 is 18. 9 times 3 is 27. Okay, so it's 3 because 4 is too much. 27, and I subtract that from the 35. I got to borrow now. So that's an 8, and that's a 0. All right, so our next step is we have an 8 here, but we can't forget about the 1 up here. So we bring that 1 down, and we have 81. How many times does 9 go into 81? Well, I know that 9 times 9 is 81, and then I have absolutely nothing left. Do I have any more numbers up here? Nope. That means I'm done. I've got nothing left. I've got nothing left to bring down. So my answer is 39. All right. Now I'm going to show this strategy to you. I call it the box. I don't know what else to call it. It's just something that I've made up over the years. And so if I'm doing 359 divided by 9, or I'm sorry, 351 divided by 9, it looks like the area model with multiplication. But I say to leave the bottom open. And I have 351, so I'm going to split it into 3 pieces. And I'm going to put a 3 and a 5 and a 1 inside. And then out here, I'm going to put a 9. So here's how this works. How many times does 9 go into 3? It doesn't. I put a 0. And then I bring this number into my next box because I didn't use it. And now I have a 35. Same question. How many times does 9 go into 35? We already know 3 times. Because 3 times 9 is 27. And when I subtract that, I know I'm going to get 8 like I did before. So here, I have to bring this up into my next box because I never want to leave anything in my box before, okay? How many times does 9 go into 81? 9 times. Because 9 times 9 is 81, and I have nothing left. So I'm done. I have no more boxes left. I have no more numbers to work with. And look, I got the same answer. So kids like this one because it helps to split up their digits. Instead of having to bring it down, you slide it over. So that's a strategy you can try. And then finally, we have the partial quotient, which is the proper name. But I like to call this strategy the big 7 because you start off with a big 7. That's a horrible line. Anyway, I'm having 351 and I'm dividing it by 9, just like all the other times. Now, the way the big 7 works is your goal is to turn 9 into 351. So I come over here and I do something simple like 9 times 1. Well, I know that's 9. But then I can use my powers, like my knowledge of the power of 10, and I can say, well, if this is a 10, then this is a 90. So now my number is increasing, and I can do that with the facts I know. I know 9 times 2 is 18, so 9 times 20 is 180. And my goal is to get close to 351. So I'm almost there. I'm going to do 9 times 3, which is 27. And when I add my 0, it's 270. So this is a fact I can use, 9 times 30, because it's close to 350. All right, so that means I am using, this is where I collect my 9s. I'm using 30 9s, and I'm going to subtract 270. I have a 1, I need to borrow, I have an 8, and this is a 0. So now I'm working with 81. And once again, I know that 9 9s is 81, and I have nothing left again. So where's my answer? Right here. First, I subtracted 30 9s, then I subtracted 9 9s, so altogether I subtracted 39 9s. I call that the big 7, but you probably called it partial quotient in 5th grade. Anyway, here's 3 different strategies. We got the exact same number each time, and I want you to find something that works for you because we're not using our calculators on this one. Let's look at another problem. Standard algorithm. Now remember, this problem reads 768 divided by 8. How many times does 8 go into 7? It doesn't. How many times does 8 go into 76? Well, I know my facts, so I know it goes in 9 times, because then I can subtract 72. I get my 4, I bring down my 8, and now I have 48. How many times does 8 go into 48? 6 times. 6 times 8 is 48. And then I have nothing left. I have no more to bring down, so I know my answer is 96. So how would this look in the box? Draw my beautiful box, and I'm having 7, a 6, and an 8. And then I'm dividing by 8. Will 8 go into 7? I cannot take that away, so no. So I bring it over, and now I have 76. And I know it goes in 9 times. And then I subtract, and I have 4 left. So I slide it up here with the 8. And 48 goes in 6 times, and I have nothing left. So once again, my answer is 96. All right, big 7. So you start with your big 7, and we have 768 divided by 8. So now I'm thinking about 8 times stuff, different numbers. And I'm using my knowledge of the powers of 10. I want to get close to 768. And something I know is that 8 times 100 is 800. So I know that's too much, obviously, but it's going to be a big number. What is 8 times 3? That's 24, so that means that's 240. That's not very close. What if we did 8 times 6? That's 48. That's not very close. It's closer, but not too close. I'm going to go again. What about 8 times 8? That's 64. And then I have my 0. I'm pretty close, so I'm going to use this one right now. So that means I have 88s, and I'm subtracting 640. I have 8, 2, and 1. So now I need to go back and figure out for 128. Well, these numbers are all too big. Well, look, if I take one of these zeros off, and I take one of these off, 8 times 10 is 80, and that's close. So I'm going to use 10 of them and subtract 80. And then I have to borrow, and then it's a 48. I need to extend my 7. Well, I know that 8 times 6 is 48. We finally got it because now we have nothing left. I ran out of room. Like I said, now we have nothing left. All right, that's a 0. So how many 8s did I use? When I add all these up, that's 80, 90, 96. Same answer all 3 times. So these are the different strategies I know have worked for 6th graders in the past. Hopefully you have one that works for you so that you can show me your work and I can give you full credit. Now sometimes we're going to see a problem like this, and I'm just going to use the box for this one if you don't mind. I'm sure you're tired of my voice already. So 8, 7, 8. And this is divided by 31. Now, I don't want you to get scared because there's 2 digits here, and that can be kind of intimidating for us. Can 31 go into 8? Can I subtract that? No. So I got to slide it over, and now I have 87. Now, some people in their head can figure out how many 31s go into 87. Other people go off to the side, and they do 31 plus 31, and they keep going until they get 87. I went above 87. So I can't use this one. So that means how many 31s do I have here? I have 2. And that means I would use 62 and subtract. And then I get a 5 and a 2. All right, so I need to bring this up. I have to slide it up. And now I have 258. Man, that's a lot. So here I am, 31 and 31. And now I can go back and can I get rid of those? I can. Magic. All right, so I need to continue adding 31s to help me figure out how close I can get to 258. Now, sometimes this can take a while, and it's up to you and what you know about addition or multiplication to help you get there faster or slower, like I am right now. Okay, 186. I'm still not there. 31, 217. I'm getting closer. Okay, if I add another 31, that's going to be too much. So I know I'm going to subtract 248 here. But how many 31s did I use? I used 1, 2, 3, 4, 5, 6, 7, 8. I used 8 31s. And when I subtract, I get 10 left. Now what do we do with this 10? Well, for this lesson, I'm just going to have you write remainder 10. We're not going to worry about the remainders right now. We're simply going to put it up there. So our answer to 878 divided by 31 is 28 with a remainder of 10. So use this strategy if it helps. I'll show you another one in the next problem. Here we go. I'm going to do the box again because it can be very helpful for some students. So here I've got a 6, a 4, a 9, and a 3. And notice I'm leaving space so I can write digits when I need to put them there, okay? And I'm going to divide that by 75. Whoa. All right, so can 75. Here's another strategy, okay? Can I subtract 75 from 6? No. So I put a 0 and I slide it over. Can I subtract 75 here? No, because I don't even have 75. So I'm going to put a 0. I'm going to put it over here. So now I've got 649. So instead of adding 75s, which some people prefer addition and they would like to do that, you could also do 75, and you could just guess a multiplication problem. So 75 times 5, let's try that. 35, 36, 37. All right, that's not close enough. I've got quite a ways to go, so I'm going to go up to 8. And let's see, 0, 4, 56, that's 60. Woohoo, I got closer. Can I do another 75? No, it would be too much if I did, because then it would be 675. So now I know I'm going to subtract 600, and I used 8 75s. 940. Now what am I going to do with this 49? I'm going to bring it up, and now I have 493. Ooh, 5 was pretty close, right? Let's try 6. I'm going to come over here. 75 times 6. 0, 3, 42, 45. Can we do another 75? No, because that would be over 500. So this is it. We can do 6, and we subtract 450, and we get 63 left. Wow, that's a big remainder. Is that right? No, because 9 times 5 isn't 63 or 6, it's 4. 4, that's a 4. 43. So my remainder is 43. 86 with the remainder of 43. All right, pause the video and try this one. You're going to have a remainder. Use whichever strategy you like. Do the standard algorithm, the box, or the big 7. Go ahead and pause it. All right, I'm back. Let's see if you got the same answer as me. I'm using the box because it really works for me. So we got a 4, a 3, a 2, and a 1 divided by 56. Well, it won't go here, and I can't subtract it from 43. So once again, I have this big number, 432 divided by 56. All right, so let's say you're like Mrs. Leith, I'm not very good with multiplication. This is another strategy you could use here. I'm going to subtract 56. All right, so the bad thing about this strategy for some students is that subtraction takes borrowing, and sometimes that gets confusing. So I know I need to borrow here, and that's a 6. And then I need to borrow here, and that's a 12. So 8. So now I have 386. Can I take another 56 away? Yeah. Can I take another 56 away? Yeah. So you can see here, I'm using repeated subtraction to figure out how many 56s go in here. And I really hope I'm not messing up my subtraction, because I'm really going with it here. I need to extend my page. I can take another 56 away. So that is, wait a minute, I don't need to borrow. See, I'm getting too caught up with the borrowing. Get rid of that. So this is 2. I need to borrow here and make this a 12. And 8, 9, 10, 12. Okay, so it's 7, 1, minus another 56. I need to borrow. 6, 1, 1, minus another 56. 0, 6. Okay, I'm getting close, and I'm running out of room. Boop. Minus another 56. 4. Finally, I have a number I can't subtract 56 from. How many times did I subtract 56? I got to go back and look. So I've got 1, 2, 3, 4, 5, 6, 7, 8. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. Well, I'm going to tell you this right now. I know the answer to this problem already, and I messed up my subtraction because I should have only subtracted it 7 times. And maybe you went in and you saw where my mess up was. So now I have to go in and look. So you see how subtraction isn't always the best strategy to use, repeated subtraction. So I'm getting rid of it. It doesn't work for me, okay, guys? I showed it to you, and it might work for you guys, but it is not working for me. And get rid of that. I much rather use guess and check. So I use the 56 times, well, I knew 8 was too much. So what if I did 5? So there's 30, 28. That's not close enough. It's kind of close, but not really. 56 times 6, that's a 6, and that should be a 3. So that's 33. That's pretty close, but I think I can do it. Oh, whoops. One more time. 56 times 7. That's a 2 and a 4, 35, 39. Oh, so 392. Now, if I added 56 to this to see if it could go in again, it's too much. See, 448. So I need to go up here, and I know it can go in 7 times. Let me try that again. 7 times, and I'm going to subtract 392. So that repeated subtraction might work for you, but it does not work for me. All right, so now I have 40 left. I got to bring it over here. Ooh, look. That's super close again. So I'm going to just do that again and see what happens. 7, 392, borrow, 9. So that is a 9, and that is 9 minus 9 is 0. That's 0, 0 and 0. So now I have a remainder of 9. So my answer should be 77, remainder 9. So I'm sorry that at first, when I was showing you that repeated subtraction, that it didn't work. But I really want to discourage you from doing that just because you could make a lot of mistakes. I really like the guessing a multiplication problem and seeing if it works. And I know a lot of kids really like this repeated addition until you get close to your number. Then you just have to go in and count how many of that divisor did you use to solve the problem. Okay? Oh, that's it. So good news, no more lesson. Bad news, now I need you to do it yourself, okay? Choose one of the strategies. You can use the standard algorithm, you can use the box, or you can use the big 7. But your assignment is attached, and I expect you not to use a calculator. And if you can take a picture of your work and attach it to your lesson, or you can bring your work in and I will give you credit for the work that you did on a piece of paper. But if I don't see your work, I take points off because I'm asking you to show your work. All right? Silly reason to lose points. So good luck. Let me know if you need me.